So,
hey everyone, good evening. I know it's been a long day, so thanks for coming. So today, So today we'll be talking about the Azure AI Model Catalog, how it offers the best collections and the tools to build awesome Gen AI apps on Azure. I'm Manoj, and he's Facundo. Both of us work on the Azure AI product team. So yeah, let's get started. The model catalog is all about model choice. And let's look at these three simple yet profound questions for why is model choice important. The first one, like, can AI solve my use case? If it can, then like, what's the best model to use for my scenario? And then like, how do I scale for real world workloads? Now, for the first question, you kind of start by building out a prototype. You define your use case, and then like, you typically pick the most advanced model with the best intelligence that's there. We call it the frontier or the flagship models, to establish like a feasibility, and then that kind of you have a prototype at that point. But then when you try to really like get it ready for production, you kind of run into all these questions. You have to answer several constraints, like what's the cost, what's the latency, is this the best model, are there any regional nuances that I need to take care when I'm shipping my model. So that's where you will like probably go look at the breadth of models that the model catalog has to offer, and you might like find that maybe there are some models that are not flagship but are better suited for your task at hand. So amidst prototyping and optimizing, like model catalog has the frontier models covered and the breadth of models covered for building your AI use cases. And towards the end of optimizing, you are ready, you're shipping probably beta versions, you are like flighting something to your prod traffic, and then you need to like scale for real world workloads, right? And when you get here, you need a system that can like monitor and grow as your workloads grow. You need like enterprise grade security and data privacy. And you need to make sure you're protecting your AI app against LLM attack vectors. All the content safety and content filtering aspects come into play here. And this is where like Azure kind of makes a difference with its most advanced platform capabilities. When we talk about model choice, I think it's very important to talk about SLMs. The sub 20 billion parameter models that have come out over the last couple of months, the Llamas, the Mistrals, the Phi3 model family. I mean, in just a year, like these are better than the flagship models that were shipped like a year and a half ago, right? So amazing progress. The pace at which models are improving is like truly astounding. And that's where like Azure AI and the model catalog comes in, from the flagship LLMs to the best LLMs, across various kinds of modalities, like the multimodal models. GPT-O shipped 2 weeks ago. It's available on Azure AI today. We are shipping a vision version of Phi3. We have had the OpenAI ADA models for embedding. Now we have the Cohere models with like great enterprise focus and multilingual capabilities for embedding scenarios. And then like the flagship models offer like advanced capabilities like function calling, JSON parsing support, all of this, so that you can build like advanced agent-based workflows. And we are going beyond just the general intelligence kind of large language models. We are focusing on regional and domain-specific models. We have had Mistral large for a few months now, which really focuses on European languages. But then like today, we are also announcing the Arabic LLM, the GIAS by Core 42. So and we'll continue to focus on these kind of really boutique models on our platform. And lastly, across the premium but proprietary models and the open models, we have got it all covered. There are hundreds of open models on the platform. Many of these come from our partnership with Hugging Face. But then over the last few months, the most popular open model releases from Meta, from Databricks, the Arctic model from Snowflake. All of these kind of arrived on Azure pretty much on the day of launch. So it's amazing the breadth that we are covering. And all of this is possible because all the awesome model provider partners that we are working with. So many of them are attending Build here. Want to give a shout out and thank for all these awesome collaborations with us. Okay, so I think we'll take a quick look at the model catalog, how to get started.
Yeah, we're here in Azure AI Studio, and we're seeing the model catalog with all the selection of models that are available today, right? So we have a very broad offering of models across different inference tasks. Like you may be super familiar with conversational models, but we also have like question answering models, summarization, text classification. So it really depends on the task we are trying to solve with these models. And also we organize these models across collections, right? So we have open source models that have been curated by Azure AI. So you may run this with all the security and trust of running software in Azure, but also from some exclusive partnerships like OpenAI, also Meta, Hugging Face, and whatnot, right? So at the end, like we have a very interesting selection of models that you can use to infuse in any of the applications that you may be thinking about.
Yeah, this is quite a collection of models. How do I kind of compare them and find what fits my use case?
Yeah, exactly, right? So with such a variety, you may get lost, like which one is the one I should pick. So for that, we have built this functionality of model benchmarking, which allow you to have a very quick understanding about which are the capabilities of the models, like a high level, right? So what we have been doing is like we collected public domain data sets, and we have executed benchmarks across for all the models that we have available in the catalog, right? So we have for model accuracy, for model coherence, and model groundness. So you can get like a quick glimpse of what are the capabilities of each of these models, what are your expectations, and then you have like make like the first selection of like, okay, this section of models makes sense for my application, this others doesn't make sense. So it's a very interesting way to get started in the selection.
That's cool. How can I try out some of these models, like a playground, getting started?
Yeah, definitely. So, I mean, the benchmarking will just get you, like as I said, like a high-level understanding of what are the capabilities, but you need to start interacting with it, right? So we have here like the playground, which is a place where you can actually interact with the model and like get a bit more familiar with it. So you can just type the question that you want the model to answer, and in this case, we're running Mistral large for example, in this example, and you can see exactly in an interactive way which are the responses, right? So in this scenario, we ask like, how does Microsoft promote the culture of giving for new employees? And I also like to get like a short answer, say like provide me a short answer, right? So we see that the model has a high-level understanding of this topic.
I'm reading this answer, but it's quite a bit different. Like when I joined Microsoft, I experienced something very unique. Is there a way this model can like ground itself and answer questions from like my data sources or something like that?
Yeah, of course. Like the model knowledge is always limited to the training data that it was just that it was training with. So you know that each time at this moment probably of the day, like you already know that each time we say on my data, we respond with RAG. So we got you covered in this scenario. Like we have the RAG pattern already implemented here on the playground. So if you use the add your data option, you're able to configure a vector index to use to ground your model and then generate answers directly out of it. So in this scenario, I already have one index already created with information about the programs for Microsoft Giving. And let's try to ask the same question and see if we now can get an answer that is grounded on that information that we just shared. So we should get back in a minute. And now we see that the response is different. And you see that more on-point answers, right? Like because it's being used some of this information that is inside of the index.
Yeah. So when we joined Microsoft, like just to get us familiar, we are given a $50 credit that we can like donate to just get the feel of the giving campaign. That's awesome. Yeah. So once you have found your model, you want to get deploying, get the APIs, get going. So there are like two broad options. One is like managed compute. This is where like the most OSS models are available. We have a very streamlined experience where we download the models to Azure VM, which is managed by us, and then we initialize optimized container runtime to provide you a REST API in that VM that you can use. This is typically built by the GPUs you're running the models on. But then basically, we also have this serverless API option, super easy to get started. The Azure OpenAI service has delivered models as APIs for 2 years now. And we recently introduced models as a service to bring a bunch of other models in the fold and offer them as APIs. So very easy to get started, cost effective because you are paying by the token. And then the Azure OpenAI service also offers provisioned capacity as you kind of grow and scale to be more effective at large scale workloads offering predictable latency. That is coming for models through the model service very soon. And all the flagship models are typically available as serverless APIs on the platform. So now that you kind of got the models deployed, you have an API, it's important to look at what the API shape is and how it kind of helps you work in a unique way. All these models are exposed to a consistent model inference API that we are working with model providers to shape and evolve. So it's very easy to kind of switch and try out different models. And these APIs are not very basic. They offer all the advanced capabilities, function calling, JSON support. And then on top of these APIs, we are building a really rich client ecosystem. We have a prompt flow that works with these APIs. We are shipping the Azure AI Inference SDK, a lightweight Python client to get going with these models. But then we are also using these APIs to integrate with the popular OSS tooling ecosystem, LangChain, semantic kernel, and all that. And then when we work with model providers, we also make sure their own SDKs and CLIs are compatible with these APIs. So you have really wide choice of client tools and platforms that you want to embrace when you work with models from the model catalog. So let's take a look at how to deploy these models, and let's take a close look at this API.
Yeah, sure. We're back in Azure AI Studio and in the model catalog, and let's experience how we can get one of these models deployed, right? So in this scenario, let's try a Mistral model family. So we have here all the models that are coming from this family. Let's pick up the biggest one. So Mistral Large is the biggest of the Mistral family. We can quickly see here in the model card some of the basic capabilities of the model. We see, for instance, it's a special iron RAG, so it has strong coding and multilingual support. So those are interesting things that you need to know ahead in time to know exactly what are you going to use. We can also see the pricing of getting this model, right? You see that this model can be deployed as a serverless API and can get built by tokens, right? So you know exactly all the details. So let's try to deploy it and get an API and start to consuming it. So I'm going to hit there on deploy. I'm going to subscribe and deploy to this specific model offering.
Hold on. I think what you did there was really connect your Azure subscription with the Azure Marketplace so that the model provider, who is Mistral in this case, can bill you for using this model, right? But where are these models running? What about my data? Who has access to all my data? Because there's the marketplace in picture here.
Yeah, exactly. That's a fair question. So all these models are hosted and run by Microsoft inside of Azure AI services. So you have all the trust and all the security practices that we run for running any type of software. So neither Microsoft or the model provider had access to the data, and it's not trained on any type of your data, right? So the marketplace is only used to bill you for the model provider.
Yeah, that's really good to know. So we are providing hosting infrastructure to model providers and then making this Azure platform place to run these models. Great.
Yeah, exactly. So if you see the deployment is ready to get used, so I'm going to just grab the URL of the deployment. And to get it started on the basics, let's use just Postman to hit this model, right? So I'm just copy the URL here. And if you see, I'm hitting the /chat/completions. And I'm going to also copy the key to get access to this model, and I'll hit it a run. So in the payload that you see here, what I'm making is just a simple request to this chat model. So I'm saying I'm configured the system message. We're saying you're a helpful assistant. You provide only numeric answers and your confidence level ranging from 0 to 1 in JSON format. right? So then what comes next is the question that the user has, which is how many languages are in the world. And I also configure the response format parameter, so I can make sure that when the response I'm getting back is actually JSON. So if I'm developing an application, this may be handy. And if you see the answer from the model, it's saying that it's approximately 7,000 languages with a confidence level of 0.85%.
This feels super familiar, like the chat completions API. I've used this with GPT-4, but I'm seeing on the last line there, like there's a safe prompt. Like, what is that? I've not seen that before.
Yeah, you have a good eye. So what is the safe prompt? So as we mentioned, this is what we call the Azure AI Model Inference API, which is a common API across all the models that we have available in Azure AI. And this API is compatible with OpenAI, but it's also extensible to allow any of these model providers to bring the unique features and the unique capabilities from these models. So we want you to take advantage of the features. And this is one of those cases. So safe prompt is a feature in Mistral family of models that allow you to prime the model in a very particular way, so you can make sure that that the model is not misused or abuse of use. So this is actually an extra layer of security that you can put in on the model, besides our standard Azure AI content safety feature that we have in Azure.
Yeah, that's great to know. Like, there's a 2-tier safety system for the Mistral models. Can you deploy like maybe Llama3 command R+, and you have already deployed Mistral, like, and show it like how can I easily use it across SDKs?
Yeah, sure. Let's increase a bit the complexity here. So what we are seeing here is 3 different notebooks. Each of them has what I use to run Mistral Large, Command R, and Llama3 7TV. And what I have installed in each of them is the Azure AI Inference package, which allows us to consume predictions for any model that is deployed as a serverless API in Azure. And if you see these notebooks are exactly the same. There's no any change of them, besides the endpoint URL and the credential that I'm using to hit it. So that's the only difference. And I would not hit like the streaming of a response, and you see all the models like replying about the same question, which is like how many languages are in the world. So all of them are the same question, and you actually see here like the difference in the styles, right, of the responses, right? Like some models may pick one style, some others may pick another one. We see Llama3 being a bit chatty here, for instance.
Yeah, it's chatty indeed. So. I like this. This SDK is coming from our team, like the Azure team. But what if I'm a LangChain guy? Like, do these APIs work with LangChain, like the OSS tools?
Yeah, so if you're a LangChain guy, like we got you covered. So we ship also an integration in the LangChain community package that you can get access to it to consume any endpoint that is deployed in Azure AI Studio. And you can use it in the very same way that you use any LangChain application. Like here, like I created a prompt template with the same question, right? Like we're always asking about how many languages are in the world, but now I'm prompting it with a system message saying like, you have to answer, making a reference about animals, right? So I'm going to run this cell, and then I'm going to construct my chain, and then ask the question, how many languages are in the world? And if you see, now the response is coming back, and it's saying like there are approximately 7,000 languages in the world, and it's also saying like there is a relationship with the number of stripes that is in a zebra.
That's interesting. Can you scroll up in the beginning where you initialize the chat client? Mm-hmm. Okay, I'm seeing that the chat client is still like, this is the Azure AI chat model client. Like, our team is shipping this, right? Yeah. I'm still not convinced. Like, show me a client that does not have any code from Azure. Like, show me that these APIs are like truly compatible.
Yeah, you're hard to convince. So as we said, like these APIs are OpenAI compatible. So that actually means that you can use any SDK that is compatible with OpenAI. You can use it also to consume the endpoints that are deployed in Azure AI Studio. And here we have one of those examples. So I'm using LLM, which is an open source project that you can use to consume any, like a very big variety of large language models. And I'm creating, again, a completion request and asking the same question, like how many languages are in the world, and also make a reference about an animal. I'm going to hit this and see what we get back from this request. Oh, there it is. I say, like, again, like the same answers, around 7,000 languages. But I say, like, to put it in perspective, imagine that the number of known birds and species is around 10,000.
Wow, languages and
yeah, so
species are like in the same ballpark. That's interesting. OK, so let's move on. So now that we have got the API and the tools covered, let's look at a simple Gen AI app. We are going to build this shopping assistant for AdventureWorks, which is our famous demo app that sells outdoor gear. And here I have a very simple pattern that uses retrieval augmented generation. We take the user question and we query it against a vector store where our data is already embedded and stored, and then we pass on the context to generate a response, and we tell the model to answer the question from the context that we fetched from the vector store. What we are doing more here is we are also adding another step, and this step is like a query transform step, and it takes the user questions, if users are asking really succinct questions, it makes it a little bit more verbose, so that it's more appropriate when you do a RAG lookup, like a vector store lookup. So those are the two things. If the question is very short, it's kind of getting expanded. So in this flow, there are two places where we are interacting with a LLM, and the middle one is actually querying a vector store. So let's look at this in action.
Yeah, sure. So I'm back in AI Studio, and now we're seeing prompt flow. And as you see, this is the flow that Manoj was describing. It has these 3 steps. The first step for rephrase the user question. The second one is lookup, and the third one is generate, right? So I want to walk you through all these steps so you can actually get a sense of what is going on each time a user hits a question in that chat experience and what is going under the hood, right? So here we have an example of a question. It says, is there any slim fit jacket available, right? So that's a user question. So that will go through the first step, which is a rephrase. And as Manoj says, this is using a technique called query transformation, which is actually trying to do is to expand the user original question so we can retrieve more relevant documents to generate a more comprehensive answer to it. So let's see how that rephrase actually ended up being. So we see that the model that we're using here is replying, saying, I would like to know if there are any slim fit jackets available, and if so, what are the most popular style, fabrics, and brand, right? So it expanded the original question to try to grab a bit more of context from this. So once we get this rephrase, then we execute a lookup in our index, right? So we already created a vector index to retrieve relevant documents so the large language model can generate an answer here. And we're using, in this case, Azure AI Search as our vector index, right? So with all the relevant information that should be usable to generate the answer should be here. We can actually see some of the documents that the search actually retrieved for this run. And we said men's soft fleece full zip jacket was retrieved as one of the documents, and all the details about that product, right? And finally, that goes to the generate step, which is also another large language model call. And in this one, what we are trying to prompt the model is to actually reason about the context, reason about the question that the user asked, and generate an answer, or a plausible answer, hopefully, about the question that they asked, right? And actually, we can see here the output, as an example that we were seeing. Let me scroll back a bit. And here it's saying, so you can see, yes, we have 2 slim fit jackets in our catalog, and it also explains a bit more about which are these 2 options, right? And in this example, what we have seen is we have been using Cohere large language model from our catalog, Cohere Command Plus, actually.
Got it. So in this example, the vector store was already generated. The embeddings were already generated, right? We are just querying the vector store. So what model did you use to generate those embeddings?
Yeah, that's your question. So in this particular scenario, we have been using OpenAI ADA model, but you can actually use, for instance, Cohere embedding model, which is actually a good choice if your data, for instance, is multilingual. So Cohere has a very interesting multilingual model for embeddings.
Yeah. I liked your 3 notebook demo where I could compare those models. And now when I'm building apps, how easy it is for me to really switch across these models and try out the same 3 models.
Yeah, I mean, PromptFlow also uses or leverages this common API that we have across all the models that we deploy. So actually, changing the model that you are using in each of these steps is as simple as changing the connection that you are using, right? So if you see here, the connections, like, is actually the configuration to consume one of those endpoints. And I already have a very interesting list of deployments here. So changing is just as simple as selecting one from here, and then you can run the flow again. Usually, if you are developing an application for your organization, you want to evaluate a bit more robustly about this change, like changing or trying a different model, right? So for those scenarios, like what we built is the evaluation option that allow you to actually evaluate the model across a data set that you can craft, and then you can always run this evaluation across multiple versions of your flow. So you are comparing the same thing over and over again, right? So you can get metrics that you can compute. And actually, I already ran one evaluation for you, so you don't have to wait. And if you see, like, what I did here, I compare 3 different models, like 𝗀𝗀𝗀𝗀R plus, Llama3 7TV, and Mistral large. So these are like all frontier models, right? And we see, like, here, we have 3 metrics: coherence, relevance, and groundedness. And all of them are like, they're pretty good, right? Like, I mean, there are some slight differences, but all of them are really good, which makes sense, because as I said, like, these are like top of the shelf, like, models, right? But we can actually see here in PromptFlow something that is interesting. Is like we see some examples about the evaluation data that was used, right? And you see here, I'm gonna highlight like the answers that this model generated, and you, again, like, you can still start to see the differences in the style that the model is using, right? So at the end, sometimes the metrics will give you like a very good first start about understanding the differences, but also the different response answers will maybe something that you also take care or worry about.
Cool. We touched a lot about SLMs in the beginning of the session, right? So in that flow, is there like any place where like a SLM fits in?
Yeah, I mean, that's a fair question. And actually, this is a nice example for showing that, because we have 2 LLMs calls, right? Like, the first call happens in the rephrase section, right? And the second call happens in the generation section. However, let's say the power that you need, or the sophistication of the model that you need to run these both steps is different. So for generate, usually you need the model that can reason across the context, reason across the user question, and generate a plausible answer. So that's a more complicated task. But the rephrase is mostly simple, right? Like, it's a user question, you just expand it, you just find attributes that are usually related with the original question, and that's it. So that rephrase is actually a good candidate for a small language model. And actually, we can actually change that for this connection directly and use a small language model. But something that is more interesting would be like to test that hypothesis, right? To see, okay, like, if I change this for a small language model, will my performance get impacted? So PromptFlow has this interesting feature, which is called variance, which allow you to introduce a change in the configuration and test it side by side. So you can see the effects of the changes that you're doing. And you can change any parameter, including the model itself. So I'm going to do that. I'm going to use the variation feature. I'm going to clone this variation. What this is going to create is an exact copy of the same configuration. So I make sure that I'm getting exactly the same thing that I was running before. But the only change I'm going to introduce is that now I'm going to select a Phi3 mini 4K model, which is a small language model. I'm going to select that one. And then, again, in the same way that I did before, I'm going to use the evaluate section to run an evaluation, again, over the same data set. And this is paramount when you're building an application, because you need to be comparing always the same thing. Otherwise, you lose track about like where you're making progress and where not. So I already have this evaluation run for you, so you don't have to wait. So let's show which are the results for this. And you see in the left we see Phi3 mini, and in the right we see 𝗀𝗀𝗀𝗀𝗀𝗀𝗀. And you see there is Cohere does slightly better, right? That Phi3 mini, which is expected. I mean, it's a much more powerful model at the end. But it's like the question here is like that performance gain, like, worth the cost that brings such a large model, right? Maybe you can run this with a fraction of the cost with Phi3 Mini and actually scale this up in your entire organization, right? So these are the kind of factors that you need to get into details to know which option is better.
Yeah, and SLM would also improve on like latency, right? So that's another thing to keep track of. Okay, so now that you know how to build apps, like let's look at what makes like Azure as a platform very unique in terms of enterprise requirements. Data privacy, security, and then like responsible AI and content safety is very important. When it comes to data privacy, as we called out, both in the managed compute option or the serverless APIs option, your data is safe and protected. Like none of the prompts or completions are shared with model providers or they are used to train future models. Security is very important for us, and that's where like we are partnering with HiddenLayer to bring in their model scanner. All the curated models in the catalog are scanned for vulnerabilities using the HiddenLayer model scanner, and in future we'll make it available for scanning your custom models as well. Security, again, very important. We'll make sure that probably there are very few cloud platforms where you can totally protect your data and make sure your data is not exposed to internet. You have like secure virtual networks that you can set up, and even the model catalog, you can download the models from the model catalog into your environment without getting exposed to the internet. So this is quite important. And lastly, not all models are made equal. You might want to think through very carefully what models you want to run in production, and that's where like you can use Azure policies to restrict the models in production, whereas like allow a much more lenient list of models to be used in dev test environments. So that's now we look at like how we are leveraging Azure AI, how our customers are leveraging Azure AI for their success in the AI journey.
Wait, Manoj, is this all you have for today?
I mean,
this is 5. I mean, all these people have been waiting here, that they are not excited enough.
Are you saying this is like Microsoft build and the bar is high? So let's see, there's something interesting.
Do you remember the days when we used to spend weeks training an regression model that could predict a few values? Now, you can do it in minutes. We are thrilled to announce Gnixla Time Gen 1, a state-of-the-art foundational model designed specifically for time series forecasting, now available in Model as a Service. Time Gen 1 can be found by selecting Gnixla collection, and it can be deployed in minutes as a serverless API endpoint. Let's see it in action at predicting, for instance, day-ahead electricity prices from a dataset. Just pass the data to the forecast function with the required parameters, and within a few seconds, forecast is ready. Time Gen 1 was pre-trained over 100 billion tokens of time series data from publicly available sources, and it can produce accurate forecasts from historical data without the need for retraining for each specific task. We can ask Time Gen 1 to predict the whole time series and see how close it is to the true data. With Time Gen 1, forecasting becomes a walk in the park. No training, no fine-tuning, just effortless, accurate, and ready to use.
Thank you, Manoj and Facundo, for the enlightening demos and insights into the model catalog. Now it's actually time to make it real and show you some concrete customer examples. Across diverse industries, be it professional service or logistics or manufacturing, companies like Ernst & Young, CMA CGM, Bridgestone, and Lenovo are leveraging AI, both large language models and SLMs, to revolutionize their operations. Each of these industry leaders recognize AI as a pivotal technology for enhancing productivity, optimizing processes, and maintaining competitive advantage in their respective fields. So first, I want to talk about Ernst & Young. They have harnessed the power of LLMs to build 𝗦𝗽𝗀, a generative AI platform that enhances productivity across various professional tasks, be it document comparison or code generation or content creation. Utilizing Azure AI technology and the model catalog, 𝗦 continuously evaluates and integrates different models like GPT-4V and Llama, ensuring that they align with specific operational needs and uphold responsible AI principles. This proactive approach not only improves efficiency, but also drives innovation across the global services. Now, I mentioned that EY is using both GPT-4V Turbo and Llama. So they're using GPT-4V Turbo in production within the EYQ chat to enable the multimodal Q&A. Whereas they're not planning to replace it with Llama, but then they're testing different models like Llama to see what makes sense for different scenarios like tax consulting, advisory, internal IT, from multiple angles like responsible AI, cost efficiency, latency, and efficiency. And with the EYQ chat, the EYQ chat has been adopted by more than 275,000 employees globally, which is enhancing their capability to perform a wide range of tasks efficiently and with great accuracy. Now, moving on to the next customer, CMA CGM. They are a global player in logistical solutions across sea, land, and air. And they have applied AI to streamline complex customer interactions in the logistics domain. By integrating the advanced Mistral model through the Azure AI Models as a Service, CMA CGM has enhanced the capability of their customer service agents, leading to significant productivity gains and heightened customer satisfaction. This move from traditional processes like RPA to AI-driven solutions exemplifies a strategic shift towards more responsive and accurate service delivery. And when we asked CMA CGM why they use Mistral, they said they selected Mistral as their language model for RAG use cases, as it performs similarly to best-in-class LLMs, but at a lower price and latency. And with Mistral, they've seen improved chatbot speed without sacrificing accuracy. And then finally, I'm moving on to Bridgestone. Bridgestone, as you all know, is a global leader in tire and rubber manufacturing, and they are focusing on optimizing supply chain operations through precise demand forecasting. Today, we announced Nixla TimeGen 1 model in the model catalog, and Bridgestone is implementing the TimeGen model from the Azure Model Catalog, and they have achieved notable improvement in forecasting accuracy, particularly during volatile periods. And as you can see, since implementing TimeGen 1, Bridgestone has observed almost a 30% reduction in forecasting errors, especially during periods of high volatility. And this enhancement in forecasting has streamlined Bridgestone's operations, and it is anticipated to further optimize their supply chain efficiency. Now that you have seen 3 customer use cases with LLMs that they've used LLMs to transform their business, I want to kind of shift the focus to shift gears and show you the power of SLMs. We recently announced the availability of Microsoft's Phi3 models in the Azure AI Model Catalog. And these models, despite their small size, are giving a run for the money even for models twice its size. So we would like to show the value of SLMs with a customer demo. And the customer we're going to show the customer demo that we're going to show is Lenovo. And you all know that Lenovo is a global leader in designing, manufacturing, and marketing consumer electronics and personal computers. And they're working closely with Microsoft to enable a broad range of applications from on-device to cloud scenarios. They are focused on advanced fine-tuning and co-engineering capabilities to deliver AI innovations that empower business to thrive in an increasingly digital world. And now we are going to show you a use case where Lenovo is using Phi3 in their ThinkPad in an on-device scenario. I would like to invite Hardik to help us walk through the demo scenario. Hardik, before we get started on the demo, I would like to first know where I can find and use Phi3.
It's as simple as going to your browser. You just need to type ak.ms/Phi3 Azure AI, and there you will have it. You will land on this page where you can find all the Phi3 models in our collection. You can chat with any of these models using the Try It Out widget. For example, I'm here chatting with the Phi3 Mini, and all I'm going to do is give it a sample query. For example, explain mathematical differentiation to a hiker, and you will see that it is behind the scenes loading the model. As soon as the model is loaded, it will give you an answer. Just wait for a minute. Yeah, we're a little resource constrained for all the demos we are running. But as you can see, Phi3 model is now generating the answer, and it's trying to explain what is mathematical differentiation to a hiker, giving an analogy of how you hike up the mountain and what is the slope and what equivalent it is in mathematics.
So from what I understand, Lenovo is using a fine-tuned version of Phi3. Now, as a customer, how can I fine-tune Phi3?
Yeah, before I show you how to fine-tune Phi3, it is important to know fine-tuning is this amazing capability that essentially, in one sentence, lets you make the model your own, right? People have used fine-tuning to induce different formats, teach different skills, or even induce knowledge. For example, and Azure makes it really simple. So all you do is, let's say you go to this Azure model card, and you will see on the top there's a fine-tune button. You just click the fine-tune button. This is a no-code experience. You can do the same with Python notebooks as well. All you do is you just point it to the data that you want to train on. For example, here I'm giving it a train data set. You can also specify a separate testing data set, or you can tell the model to distribute the training data set into test and do a validation split. If you are an advanced user, all you have to do is click on advanced settings, and here you can specify all the parameters that you would use to fine-tune a model, including LoRa. And remember, LoRa is this amazing technique that gives you better efficiency. It essentially creates an adaptation layer on top of your base model. And so if you have many customers who want to fine-tune, you can use Azure platform. You can essentially fine-tune for each of those customers using LoRa, and you get better efficiency for the GPU that you're using.
So it's great to see how easy it is to fine-tune Phi3 in the model catalog. Now, I'm curious, how is this fine-tuned version of Phi on the Lenovo ThinkPad different from the non-fine-tuned version? In short, where and why would I consider fine-tuning a model? And in this case, is the fine-tuned model better than the vanilla model?
Sure. So when you think of any foundational model, think of it like a person who has just done graduate school, right? Like they have some understanding of the world, some facts, some knowledges. But if you ask a very deep question that they might not know, that is when you can induce fine-tuning. So let me actually show you. I'm going to ask a simple vanilla model, Phi3 model, and Lenovo's fine-tuned model, a question that is very specific to Lenovo. So I'm going to ask, let's start with first Lenovo's app, right? I'm going to ask, what is Vintage application? And this is an application that Lenovo ships with every machine that they send out. Let's see what it comes back with. So it's an application, user-friendly software tool designed by Lenovo to help manage, configure, optimize your computer settings. Great. Now I'm going to ask a deeper level question. So I'm going to ask, does Vintage app support remote technical services? Which is basically, if I get stuck, can the app help me call the support person, share my screen, and debug? You will see on the left, Phi3 model comes back, but I cannot respond to that question because it doesn't have that information, or at times it will hallucinate. But on the right, it comes back with that exact answer, which is just showing that how Lenovo has used the fine-tuning capabilities to induce knowledge and make it their own.
So I see that you've been asking questions to the Lenovo ThinkPad about its spec and all other configuration settings. Now, what if I'm offline? And can I still interact with this model and get the answers I need?
Definitely. In fact, all this, at least on the right-hand side, the Lenovo app is running on device. And to make my point, I'm going to turn off Wi-Fi, right? And then let's ask a silly question, right? Like, for example, how can I explain artificial intelligence to my grandmother in a funny way with an example? On the left, I'm using still the Azure, and it kind of bails out because there's no internet connection. But on the right, you can see because the model is running on device, it comes back with an answer.
So from what you're showing, Phi3 models are great for edge and on-device use cases, and we can get offline responses. And I can see how SLMs are going to cause a big disruption. You've been showing all these natural language use cases for Phi. I'm wondering if there are any plans for bringing multimodal capabilities to Phi.
In fact, yes. Just this morning, we announced Phi3 Vision, which is a multimodal small language model where you can do vision, image-related question and answering on top of it. So let me just refresh the tab because I disconnected the Wi-Fi and connected it back. Now I'm going to ask it a very interesting question. So this is, let's say, floor plan of my house, and I'm going to ask, like, if I want to install hardwood in my living room, how much area are we talking about, right? And you see here, I gave it a floor plan, right? and I am actually asking this question, and the floor plan says that living room is 14 by 23. So Phi actually used its vision capabilities to figure out where the floor plan is, what the dimensions are there, and it did the math and came back with an answer which is 322 square feet.
OK, now
And by the way, 4.2 billion, take it in your pocket and run, right? So that's what Phi3 is, explosive power in a small package.
OK, now you have me hooked because we are planning on a home remodel and renovation. And I can see how these vision models can become my personal assistant and help me make decisions faster. Thank you, Hardik. And earlier today, Satya talked about Copilot and PCs. And we have shown you a very good example with our Lenovo demo on how that can become a reality on any PC. All the stories, customer stories that I have shown you underscores a shared narrative, which is AI is a driver of business transformation. It's not a hype. It is very real. And we are seeing enterprises and organizations using them in production scenarios. That's pretty much all we had. Thank you so much for attending our session. And we have some great resources for you to get started, so please check them out. And also, we have some related sessions that will be doing a deep dive on prompt engineering, RAG, and fine-tuning. So be sure to check those sessions out as well. Thank you.